In this video, we'll be going through the installation process of the RxG software on our lab machines. We're going to be creating a cluster of 2 RxG machines. Basically, we're going to have a master controller and then a standby controller. We're going to get the software installed. We're going to cluster them. And then we're going to get the WAN IP address information on there so that we can access them remotely, followed by creating our networking that we're going to use for our guest and account, or our onboarding in our guest network or account network. After that is configured, then what we will do is go through the process of actually configuring the policies, which basically define the end user's experience when they connect to our network. So before, where we're going to start, let's take a step back. What we're going to do is we're going to start by installing the software. So I'm going to remotely connect to the IPMI ports that we have. And for my first machine, it is the actually, in order to save time, I've already got my lab installed on the 41 address. So I'm going to show you the process of installation on the .31 and .32, and then we'll switch to the other machines. So we'll go ahead and bring that open. Same thing with the 32 address. And again, this is the IPMI port of the Supermicro servers that the software is installed on. So I'm going to go ahead and log in here. I'll do the same thing for my second box. All right, so the first thing that I'm going to do here in order to reinstall these, so basically the way this is set up is these servers have a USB drive plugged into the USB port that has the ISO, or excuse me, not the ISO, but the image, basically a bootable USB stick plugged into the USB port. We're going to use that to install. So to do that, the first thing I'm going to do is I'm going to go to Remote Control and then the IKVM HTML5 button. I'm going to go ahead and click that again. That'll open up the window so that I can actually get the remote console here. And as you can see, the software is in fact already installed on here, but what I'm going to do is I'm going to go through the process of installing it again. So to do that, I'm going to open up my keyboard, because what I'm going to need to do, because the USBs are in the machines, we can't have it set to boot off of the USBs by default, because if we do, then we'll just get into a boot loop. So now that I've got my keyboard open, I'm going to go to Power Control and then Set Power Reset. So this is going to reset the machine. And when I do that, I need to hit F11 on the keyboard here. And what that's going to do is invoke the boot menu. Once I have that boot menu, I'll be able to select the drive to install to, or from rather. And we're going to select the USB drive. Let me make sure I keep pressing F11, because if I miss it, then it'll boot. There we go. So down at the bottom left, it said invoking boot menu. So to install this software, it's pretty straightforward. All I'm going to do is go down to this UEFI SanDisk Extreme Pro. That is the USB drive that has the image of the software on it. So I'm going to go ahead and hit enter. This is going to boot off of that. And we're doing this to 2 machines. I'm only going to do the install process on one. It's the exact same on the second machine. And I already have the lab machines installed, because this process takes about 20-30 minutes roughly. And so to save that time, I've got the other systems just pre-installed. And the purpose of this, so I'm going to tell this yes. I'm going to tell yes, I would like to begin the installation. There's a previous installation that's detective. I want to overwrite it, so I'm going to tell yes. Then it's going to ask me if I want to use the same name for the file system. I do, so I'm just going to hit enter for OK. So then, now the software is installing. Now the purpose of this, when we get to the end of this, basically what we're configuring is we're just going to really quickly go through the process of installing the software, forming a cluster, getting the WAN on there, and then configuring the system as if it were set up for an MDU. As part of this process, we'll be creating the networking. We'll also be creating, of course, the VLANs to go along with the networking because we're going to use dynamic VLAN. So what does that mean? In this case, every account that connects to our network will get its own VLAN. So they'll be in their own VLAN and they'll be in their own subnet as well. And so what this is doing now is just preparing to install. It's going to copy the files and then it's going to reboot. And then as part of after it reboots, it's going to continue to do the installation. And for that, it'll take you to a screen that says it's installation, initializing, please wait. And all we have to do there is do exactly that, please wait. But in our case, we don't have to wait. So while this is doing its thing, installing the software, and this is really the only thing we have to do at this point, it's all going to do it automatically. We don't have to intervene in any way. And when it's done, we'll be presented with a screen that looks something like, I'll go ahead and bring up my 192.168.15.41. So I'm going to go ahead and open this, log in. We do the same thing. So I'm going to go to remote control, IKVM. I'm going to click this IKVM button. This takes us to the CLI. And after the system is installed, this is the screen that it's presented to you. And we have a couple of different options that we can do here, as you can see down at the bottom. So we can choose from the following, right? We can configure the WAN, the LAN, we can get into the shell, we can reboot, shut down, enable the built-in admin sync, display the IUI, or 8 exit. In this case, I don't really need to do anything here. The only thing that I'm interested in here is the IP address it got on the uplink, which we can see this is on IGB0, and its IP address is 192.168.15.139. And that's what I can use to access the system. Another thing that I could do is I could configure the WAN, I could configure the public IP address on there, and then I could connect to it that way. Remember, these are remote machines, and the way that I'm accessing them right now is through an open VPN connection. So I've got my IP address, 192.168.15.139. So I'm going to go ahead and open a new tab, 192.168.15.139. Now /admin. If you don't put a /admin on there, if we don't put a /admin on the end, it's just going to take us here. A valid license key is not installed in this Bane device. If you get to that point, it just means you've got connectivity to it. You just need to put a /admin on there. And now when I do it, it'll take me here. My connection's not private. We don't have SSL certificates on here yet. Not to mention, we're also hitting it from the IP address, the private IP address. So now I'm going to go ahead and I'll go ahead and close the .31 and 32 windows because we don't really need those anymore. In fact, you can see this one's still installing, and I'll leave that here just so I can show you that at some point it's going to go back to, it'll look like this one here. So this is our CC, this is our master CC, and right now this is the only one that I want to do anything on. Now, after you first installed the software and you've done nothing else, you're going to be presented with this screen here. From this screen here, we just need to create an administrator and then add in a license. So I'm going to go ahead and create an admin. The only required fields here are the username and then the password and the confirmation. The other fields are optional. And so I'm just going to go ahead and hit create. So now I have my administrator in here. Now I need my license. I've already retrieved the licensing, so I have it here. I'll go ahead and copy the license. Now the process for this, to retrieving a license, is we have this installation unique identifier, which is right here. Basically, you copy that, you go to the RGNet's licensing portal, find the asset that you are installing. You can copy that IUI into the IUI field, and then you'll be able to retrieve the license after setting a fully qualified domain name as well. So I've got my license. I'm going to go ahead and edit it here. I'm going to go ahead and paste that in. Now, one thing that you should note, if this IUI was already attached to an asset and I installed, like I had to reinstall for some reason, the system would actually be able to find that as long as the system is connected to the internet, it will be able to retrieve its license key automatically, and you don't actually have to do that step. So now I have the first machine installed. It's got an administrator on there and it's got a license key. The second machine is installed, but I'm not going to bring it up just yet because when you are working with a cluster, all of the configuration is going to be done from the master controller. Now in this case, we do need to touch the standby controller at least a little bit because it is not currently clustered, right? So what we need to do is once we bring it into the cluster, we'll have to access its basically the same page we're on right now, but we're not going to create an administrator on there, and we're not going to create we're not going to add the license there. It'll gain the administrators when it joins the cluster, and then we'll also license it from the cluster itself. So the first thing that I need to do, or the next thing that I need to do, is to create the networking that we're going to use for the cluster. So in this case, I'm going to go to network and LAN. Now it's just been installed. I just licensed it, so it's restarting the web server. So while we wait for that, I'll go ahead and I will bring up the .42 machine just so we can get the IP address for that, because we will need it after we turn the system into a cluster. So we go ahead and log in here. And again, all I'm doing here is just going to retrieve the IP address that the system has. So I go to remote control, IKVM, HTML5. I'm going to go ahead and click that button. This will open up that screen so we have access to the CLI. And there I can see that this one got an IP address on its uplink of 192.168.15.137. When you first install these systems, the first physical interface is going to be the WAN interface, or the uplink interface. And by default, it will accept an IP address from a DHCP server. So we can access it that way, and that's how we're accessing it, right? This is plugged into essentially another RxG, and it's getting its IP address from there, and then we're able to access it that way through the VPN. The other way that we could access this, if I was local to the machine, is the last interface, in this case IGB3, is configured as the LAN interface. And it's going to hand out 192.168.5 addresses to anything that's plugged into the LAN on it right now. So that's another way that I could access it. If I was, in the same room, I could just plug my laptop into that. It would hand out a DHCP address, and then I would be able to get to it that way. So in this case, I just want to get the IP address. It's the 137. So now I'm going to go up here, 192.168.15.137/admin. And again, on this second system, I don't want to do what we did on the first one. I don't want to create an admin, and I don't want to create or add in the licensing either. So I'm going to hop back here. So the next thing that's required, so now that the web server is finished starting on our first machine, I can now create the network address for the cluster network. So to do that, I am going to, first thing I need to do is decide which interface I'm going to use. The cluster network there should be no other traffic on that network. So IGB0 I cannot use because that's our uplink. IGB1 I don't want to use because that's actually going to be where our public IP addresses reside. That's where our public uplink is going to be. IGB3 is our LAN, so that basically leaves us with IGB2 for our interface that we're going to use for the cluster. So for that, I'm just going to create a new network address. And I'm going to give it a name. In this case, this is going to be CC1. It's going to be the first controller. The name really doesn't matter so long as it makes sense to you, but this is going to be my SIN, so cluster. It's basically the cluster network. The Ethernet, I want to make sure I'm using the right interface. In this case, I want to use IGB2. I'm going to specify an IP address, and for this I think we're going to use 172.16.0.1. Now and it's a /24. Now in our lab here, we do have some other devices that are on that network, which is we have an ICX switch and also a VSZ that is on that network. Now, if this was a real deployment, those devices should not be on that network. For the purpose of this lab, it's okay. So what I'm not going to do, I'm going to leave auto increment at 1. Span is going to be at 1. I'm not going to create a DHCP pool for this address, for this network. At least not by checking this box. I'm just going to hit create. And again, I'm going to go up to services and DHCP. So anytime we create a network address, we can check that box that will the create DHCP box, and that will automatically generate a DHCP pool for us. In this case, I didn't want to do that, but you can see, even if you forget to check that box, if I come here, if I come to services and DHCP, I can click create new for DHCP pools, and it's going to give me the information from the last address that I made. In this case, it was the cluster on the 172.16.0.2. Now, I'm not going to create a DHCP pool. I just wanted to point that out. So now I have my cluster address. Now I can actually turn this system into the master controller. Now to do that, I go to System and Cluster. I'm going to create a new cluster node. Now here it's going to fill out everything for us. I am going to check the auto registration. That just enables automatic registration of cluster nodes, so that when I bring in our standby controller, it's going to join the cluster automatically. But I also need to check permit new nodes. And then I'm also going to auto approve new nodes. This way I don't have to do anything. I'm just going to point the second controller at this one, and it's just going to form a cluster automatically. I do want to verify that the IP address is correct, 172.16.0.1, so that is correct. The only other thing I might change, and I'm not going to be doing any upgrading on this machine, but I'm going to go ahead and check this upgrading box here. And that just says, right now what we have is an HA, what we're going to be creating is an HA cluster, meaning if one of our boxes go down, the other one's going to take over for it. It's going to take over the networking of that down machine. There are, by checking this upgrading box, when it is being upgraded, it will turn off the HA stuff. And so that's just so that if one of the systems finishes before the other, you don't have a down event, basically a failover event where like maybe the standby finishes first, and so then it takes over for the master controller because it's still doing the upgrading. But by checking this box, we don't have to worry about it. As long as it's doing an upgrade, it won't try to take over for the other system. Now I'm going to go ahead and create this. So I'm going to hit create. When I do that, that's going to cause the web server to restart. And so what you might see is this message that says, it looks kind of scary, right? Request failed, code 500, internal error. But that's just because when we turn this into a cluster, one of the things it's doing is it's got to restart the web server. So if I refresh this page, now you can see we're restarting the web server, and we just need to wait for that to come up. While this is restarting, I can go over to our standby controller and I can get ready to point it over to our master controller. So to do that, I am going to scroll down. You might remember from the other machine, what we did was we created an administrator and we applied the license key. I'm not going to do that on this system. Instead, I'm going to scroll down to the bottom where we have the bootstrap options. I'm going to edit the bootstrap options, and then from here we see the same things we saw on when we created the cluster controller. I can enable automatic registration. In this case I do. It's going to join as new, and then I can select a join role. Now in this case I want to do standby controller HA. That's what's going to enable if one of these systems goes down, the other one will take over for it. If I just did a standby controller, there would be no HA. Basically, if the system went down, it wouldn't take over the networking for the other one. So I'm going to leave this as standby controller HA. Then I need to specify the controller, in this case the master controller's IP address. That was 172.16.0.1. Now, before we turned it into a cluster on that master, we had to create the networking. Well, because this does not have a license on it right now, I can't do the same thing I did before. So I can't go to, if I try to navigate anywhere, like if I'll come up here, I'll go to network and WAN, we'll do it in a new tab. It's going to take us back to this same screen, basically the screen we were just on, because it's unlicensed and we don't have an admin on here. It's not going to let us navigate anywhere in the system until we get a license on there. And so here you can see it's the same screen we were just on. So I'm going to scroll back down to the bottom here. I want to do the create SYN. That's what creates the cluster network, basically the cluster interconnect network. We want it to be on IGB2, and we need to change the IP address. This can be 172.16.0.2/24. And in this case, because they're on the same subnet, we do not need the gateway. Just going to verify that my first system is up. The web server is finished restarting. So now that it's finished restarting, I can click update here. Just going to quickly verify my controller IP 172.16.0.1. So that's correct. We're creating the SYN. Interface is set to IGB2, and we've got our IP address on here on the cluster network for this machine. So I'm going to go ahead and hit update. And this will take it a minute or so, and what it's going to do is it'll join into the cluster here. And when that happens, it is going to restart the web server again, so we'll have to wait for that. But it will do it automatically. We don't need to. In fact, we just got the error 500, and that's because this scaffold is trying to refresh, and it was trying to refresh, and the web server is restarting. So now we just need to wait for the web server to come back up, and then we can license our standby controller. This particular cluster that we're creating now is a symmetrical cluster, meaning that all the nodes in this cluster are the same. Basically, they're both cluster controllers. It's possible to have an asymmetric cluster as well, and that would be a combination of just data plane nodes and cluster controllers. And this usually just takes a minute or two to restart. All right, so now our web server is finished restarting, and we can see that CC2 is here. And we've got our replication, and what this replication is doing is, because this is the cluster controller, it's got the database stored on it. Now what it's doing is it's pushing a copy of that database to the standby controller, and that's what allows it to, if this box, one of the machines was to go down, like our primary, if our master controller was to go down, then the standby controller would be able to take over for it. And because it has a copy of the database. So right now, the state of this CC2 is it's unlicensed, but we can license it from here. As you can see, here we've got our licensing keys, and we've got an entry for CC2, but it is blank. So I'm going to go ahead and edit this. It's got our IUI here. I'm going to go ahead and grab the license key. And I'm going to hit update. Oh, and it seems like I may have made an error when I generated this license. Just make sure I didn't paste something incorrectly. All right. Give me 1 second here. What I'll need to do. Is regenerate this license. And this will take me just a second. I need to do this from a different machine that I'm connected to. And this IP address is 15.139. All right. So now what I will do is I will get the license generated. All right, I was able to input the license in on the other machine, basically same process. I just copied and pasted it in. And now we can see that we now have an active license. Now that we have that, now we can configure our WAN. All right. Okay, so the next thing we're going to do is configure our WAN settings. So now we have a cluster. Actually, before I do that, I want to do one other thing. So the other thing I want to do is cluster node teams. I'm going to go ahead and hit create. And it's not really necessary here, but I wanted to create that. If we had more nodes, and actually that's going to restart the web server. If we had more nodes, we can create teams. Basically, we can control what machine is going to take over for another in the event of a failover. So if we had multiple nodes spanning across different hosts, for example, if we were using, for example, VMs like ESXi machines, and we had multiple hosts, we can configure how, basically what machines are going to take over for the others in the event that there is a machine that goes down. Or in this, probably, if it's in ESXi, then it's probably a whole host that's gone down. But in that case, it's just going to determine, which machine will take over for another. I'll go ahead and refresh this. So when we go to do our WAN configuration, there's a couple of things we need to do before we assign the public IP addresses. What we're going to do is we're going to set our fully qualified domain names, and then we'll configure our IP addresses on the WAN. And then once we have done that, we can then get the certificates generated for the system. And for that, we'll be using Let's Encrypt. And that is all built into the system. So we will go over that process. All right, so it looks like it is loading now. All right, perfect. So the first thing I'm going to do is to configure my fully qualified domain names. As we can see up at the top here right now, this is currently cc1.rxg.local. That is not what I want to use. So to change that, I'm going to go to System and Options. Now here I'm going to start with CC2, and the reason for that is when I edit the options for CC1, when I update them, it's also going to restart the web server, and then I would have to wait. So I'm going to edit CC2. I'm going to verify that its time zone is correct. In this case, it is. I am on the West Coast. So the fully qualified domain name here, I'm going to make it lab04-cc2.netlab.ninja. And that's the only thing that I need to do here. I don't need to change anything else. And so I'm just going to hit update. Now I'm going to edit the record for CC1. And that's going to be lab04-cc1.netlab.ninja. Again, it's in the correct time zone already. The only other thing I am going to do a little bit differently here is I'm going to click Show next to Advanced. And I'm going to click the Sync Built-in Admins. Now, what that does is that will add in the RGNets administrators, basically add their admins to the system. More importantly, it adds their SSH keys so that they have access to the system via SSH. And that's useful for if you have a problem with the system, for opening a trouble ticket, basically. Or when you open a trouble ticket, it allows us easy access into the machine. That way we can actually assist. So I'm going to go ahead and update here. While that's doing that, it's going to restart the web server again. Or it will here in a second. There we go. So now it's restarting the web server. So now we've configured our fully qualified domain names. The next thing that we're going to do is to create our uplinks. And then we will create the network addresses that go along with that. Each of these two systems is going to have 2 public IP addresses assigned to it. All right. So the next place we're going to navigate to is network and then WAN. Now we're going to have multiple uplinks configured on these systems, which is basically SD-WAN, right? More than one WAN connection. But what I don't want right now is the priority of these is 9. And these uplinks, while they do work, this is how I'm accessing the system, is over these uplinks. But this particular way that these uplinks are configured right now are not supported by RGNets. The reason for that is it's not only is it not a static IP address, but it's a DHCP address. and it happens to be a private IP address. And that is not, it does work, but it's not officially supported. Now, the highest priority uplink is basically what defines the default route. In this case, I don't want our private uplinks to be the default route. So I'm going to edit both of the uplinks. I'm going to change the priority from 9 down to 5. Now, it doesn't have to be set to 5, just anything lower than 9. But I'm just going to set it to 5. And then update. The other thing, actually, before I move on, the other thing to point out is the speed here. Now, these should be configured what the actual speed of the uplink is. And the reason for that is, let's say this was a 100 megabit pipe, and we configure it for 100 megabit or 100 megabits, which would be correct. If we had, with no other configuration on the system at all, if 10 users were to connect, they would each get 10 megabits per second. If they all tried to download something, there's basically a fair use algorithm running in the background. It's not going to allow anybody to become bandwidth starved, right? It's going to split the available bandwidth equally. But that's based off of what is defined here. So if this was only a 100 megabit pipe and I set this for 1 gigabit, that's going to be a problem, because now if I had 10 users on, it thinks that each one of them can get 100 megabits per second, when in reality they can't. The pipe is only 100 megabits, and then it's going to be trying to give everybody 100 megabits per second. So we could end up with basically one user who gets a good experience and the other 9 that don't. Now, it's okay if this was a 1 gig pipe and we set it to 100. That's okay, because now we're under. I mean, it will cap our bandwidth, but it's not going to cause any problems with like the fair use sharing algorithm. So I'm going to set these to 1 gig, and then I'm going to hit update. And I'm going to do the same thing for the first uplink. I'm going to change it from 100 megabits to 1 gigabits, and then hit update. So now I can create my other uplink. So I'm going to create new. This is going to be CC1. We'll call this one public uplink, because it actually has our public IP addresses on it, or it will. Now I need to select the interface. This is going to be CC1 IGB1. It's not going to be DHCP, so I need to uncheck that. And then I need to enter in the gateway. For this, it is going to be 47.48.73.193. And it's not IPv6, so I can leave that alone. I'm going to change this from 100 megabits per second to 1 gigabit per second on both of them. I'm going to go ahead and just double check really quick. So I've given it a name. I've left the priority at 9, which is correct. The Ethernet is going to be CC1 IGB1, and then I've entered in the gateway IP, and then I can go ahead and create. So now I've got my secondary uplink, or rather my primary uplink, the second uplink, which is going to be the primary. It's still not working right now because we haven't assigned any IP addresses to it. So I'm going to go ahead and create one more uplink. This is going to be our CC2 public uplink. The Ethernet here is going to be CC2 IGB1. It remembers the last thing that we did, right? Which is why DHCP is unchecked and our gateway is in here. The only other thing I need to do is just change the speed so that it is set to 1 gig. And then I'm going to hit create. So now we have both of the uplinks created. Now I can actually create the network addresses and add the public IP addresses in. Now, once I do that, right now I'm hitting this on the private IP address, which is our CC1 uplink, our private DHCP uplink. When you're accessing the GUI, the admin GUI for these systems, you should be hitting it from the IP address that's on the primary uplink. So once I make this change, I will no longer want to hit it via the private IP address, but rather the public IP address. So to add the addresses, I'm just going to go to network addresses. I'm going to create a new one. I'll do CC2 public addresses. I need to select the proper interface. So this should be CC2 IGB1. And then I want to check the primary box, because this is going to be the primary IP address of the RxG, the first IP address that I put in here. If I add more WAN addresses, like if I created another network address that was also on CC2, I wouldn't necessarily have to check that primary. I wouldn't need to check that primary box because it's just additional IP addresses that could be used for either CGNAT or to basically do one-to-one NAT for end users. So my IP address here on this particular system is going to be 47.48.73.216, and it's a /27. Now I'm not gonna. I want to consume .16 and .17 on this system. Now I could create this, and I could create another network address, and then create it for 217. But imagine if this was a /24, and I was trying to add 250 IP addresses in here and create a record for each one. That would just be too time consuming. So I can utilize the span functionality here. And so it just says the number of aliases configured incrementally. So if I change this from 1 to 2, that means it's going to consume .216 and 217. If I set it to 3, then it would be 218. But I only want 2, so I'm going to set the span to 2. And now when I create this, we're going to see that you can see right here that it's got the span basically 47.48.73.216 to 47.48.73.217. And now I can create another network address, which is our CC1 public addresses. The Ethernet for this one is going to be CC1 IGB1. The IP address here is going to, if you want to remember, I want to check that primary box, but it's going to be 47. I made a mistake actually on the other one. I need to go back and edit this one. This was the CC2 IP addresses, which means this actually starts at 218. So I'm going to go ahead and update that here. And so now we can see we're at 218 to 219. So now I can create my CC1 public addresses. I want to make sure to put those on CC1 IGB1. I'm just going to make sure that I put that one. Okay, CC2 IGB1, so that's correct. I'm going to check the primary box. And this time it is the 47.48.73.216 /27. Again, I'm going to set the span to 2 because I want to consume 2 addresses from that /27 block. And then I'm going to go ahead and hit create. So now I've got our public IP addresses on here. Now what I should be able to do is hit it via the public IP address. We do have some domains that already have resolved to those. So I can go to lab04-cc1.netlab.ninja/admin. And now I am accessing the system over the WAN, but the issue right now is that I don't have a certificate on there, so it is not secure. But I'm going to go ahead and log in. So now our next step is to get the certificate installed on the system. To do that, I am going to go to System and Certificates. And I'm going to create a new certificate. I'm going to select the node. This is going to be for CC1. I'm not going to check active yet because active makes the certificate active, and I don't have the certificate yet. I'm going to go ahead and enter the name. This is lab04-cc1.netlab.ninja. I'm going to go ahead and copy that because I'm going to scroll down here, and then I get to do a certificate signing request. I'm going to give it a name. Typically, I just use the domain name. Makes it easy to know exactly what it's for. The usage is server. And the sign mode, we want to change from trusted third party to certificate from Let's Encrypt. It already has the common name in here, and that's because I selected the node in the record up above. Then I need to put in my country code, the state, and then the locality. The other fields like organization and organizational unit, those are optional. I'm going to go ahead and put in an email address. I'm just going to do info@rgnets.com. And I'm going to go ahead and hit create. And it will take it a minute for it to download or to retrieve the certificate from Let's Encrypt. So now I'm going to go ahead and create another one of these. I'm going to select CC2 this time. This is going to be lab 04-cc2.netlab.ninja. Go ahead and copy that again. Paste that into the name. Let's encrypt. Country code US, state Nevada, locality Reno. Email address is going to be info@rgnets.com. And then I'm going to hit create. So that will retrieve the 2 certificates we need for basically and we can see CC1 has already retrieved the certificate. I'm going to make one more of these, which we're not going to use just yet. And we'll talk about it a little bit later. But what this one is going to be used for is to access our virtual smart zone over the WAN. So I'm going to give it a name here. I'm going to change it again. Still, let's encrypt. This time I need to put in the common name because I didn't have a node selected, so it didn't pull that automatically. Country code is US, state is Nevada, locality is going to be Reno, and then same thing for the email address, info@rgnets.com, and I'm going to go ahead and create that. So now what I can do is I have so now the certificates have been retrieved for both CC2 and CC1. So I'm going to edit. All I need to do to make these active is to edit them at this point and just click the active checkbox and then hit update. So I'm going to do that for CC2 and CC1. Check active, hit update. And now I should be able to go to lab04-cc1.netlab.ninja/admin, and I should be secure. And we can see that in the upper left here, so right next to our domain name. Now we've got the little lock icon. So now we have a secure connection to our CCs. So now that we have, so what we've done, just to recap what we've done so far, is we installed the software, we licensed the primary box, we created the cluster network on there, we turned it into a cluster, then we pointed the standby controller to the master, and it formed a cluster automatically because we had the automatic provisioning all enabled. And then we changed the fully qualified domain names on the system by going to System Options. And then we created our 2 new uplinks, put our public IP addresses on the system, and we retrieve certificates from those utilizing Let's Encrypt. The next thing that we're going to do is one of the features that the RxG can do is it can take over, depending on the networking equipment that you're using, it can take control of that equipment so that you can easily push configuration changes to it. So on this, connected to this lab systems, we have an ICX switch along with a virtual smart zone. So we're going to take control of both of those. So in order to take control of the switch first, I'm going to go to Network and Wired. Before I actually take control of it, this current switch is not in the factory default state. So what that means is it already has the IP address and everything that I want assigned to it. It already has the configuration on it to actually get connected to the RxG. Now, so I'm going to show you what it would look like if the switch was not, or the switch was factory defaulted. If that was the case, we would create a new switch. We'd give it a name. In this case, it's just going to be ICX. We would change the type to Ruckus ICX switch. Now, here we would give it the IP address that we want it to have, not an IP address that it has, but the IP address that we want it to have. So in this case, I'm going to select, I'll just do .16 because there's nothing on that. Then I just need to specify the password. And again, this would be what the password is, or rather not what it is, but what you want it to be. Go ahead and enter the enable password as well. So I'm going to go ahead and create this. And what that's going to do is, because the system can't ping this switch because that's not its IP address, if I click this sync not enabled, it's going to give me this option that says download bootstrap configuration. And if I do that, I'll go ahead and download this and save it. So what that does is it generates this file here. And there's basically a phase 1 and a phase 2. Phase 1, we run first. That's going to cause the switch to reboot. After the switch reboots, we can basically copy this block of phase 2 and then paste that into the switch. And that's going to set it up so such that it can be controlled by the RxG. But it's also going to specify its IP address. And that's why you want to specify the IP address that the switch that you want the switch to have and not the IP address that it has. Now I'm going to go ahead and delete this switch because it's I'll go ahead and delete it. So I'm going to go ahead and delete this switch, and it's going to create a new one so I can show you the in this case this is not a factory defaulted switch, so I need to specify the host. It's going to be 172.16.0.4. I'm going to put in the username. The username is still admin. And I'll put in the password and the enable password. And then I'm going to hit create. Now, if I give this thing just a second, in fact, you can already see it brought now, because it's the correct IP address, it pulled in the model, it pulled in the ports. And if I refresh this screen, we're going to get a little bit more information here. So it's pulled in the ports, and it also created this switch port profile. And what the switch port profile is, if I edit it, it's just a list of all of the ports, and then I can use this to configure the switch. So if I wanted to push a VLAN to all of these ports, I would select it here. Now, we don't have any VLANs configured on this system yet, so I don't have anything to select. And I could specify an untagged VLAN here if I wanted to. I'm just going to click cancel because I didn't change anything. So now that it's online and it's pulled in all of this information, I'm going to click the sync not enabled. And this is going to be different this time because it's actually able to communicate with the device. If I click this sync not enabled, let me try refreshing this page. So now I'm going to click the sync not enabled, and this time instead of the button to download that bootstrap configuration, instead I get a button that says generate diff to enable sync. So what this is going to do, if there's any configuration on that switch as far as VLANs go, it's going to try to match it to what's on this system here. So if I had VLANs configured, it will remove those VLANs. Now it's going to tell us what it's going to do. So in this case it says that it's unable to establish the connection to this device. And I think I might know what the problem is. There was an issue. I'm going to see where it's using the API port instead of the actual SSH port. I'm going to see if that's still the case here. Yeah, so now that I've changed that port, now it's, and what it says here is no changes required. So what that means is that the settings on the switch, basically the VLANs on the switch, match what's on the RxG. I don't have any VLANs configured on the RxG, and there's no VLANs configured on the switch. So I can just go ahead and hit enable config synchronization. It's not going to make any changes to the configuration on the switch, but it's going to allow me to push configuration changes later. So now I've taken control of the switch. Now what I want to do is to bring in the wireless. So I'm going to go to network and wireless, and I want to take control of the virtual smart zone that's also attached to this lab. The process is the same for the most part. One difference is, though, there is no bootstrap file here. Here we actually do want to, as part of the installation process for the VSZ, actually giving it the IP address and all that. So I already know what the IP address is here. I'm just going to call this VSZ for virtual smart zone. I'm going to select virtual smart zone here. The host, in this case, it's 172.16.0.5. I'm going to enter the password. And then hit create. Now, this is a little bit different because if there's already, and I believe there are there's at least one WLAN on the VSZ already, what it should do is bring in that, instead of like on the switch, if the configuration didn't exist in the RxG, then it tries to make the switch match that. In this case, I don't. It's not. That's not going to happen here. It's going to pull in the existing configuration, if applicable. So here we can see it's pulled in some access point zones, basically the staging zone and then the lab zone. I can also click import here, and I could select the zone, click import, and then it will import anything that goes along with that. And you can see that because I did that, it pulled in not only the access point profile, but the WLAN that exists on there as well. So there's already a WLAN on there that's called Lab 04. So if I was to connect an AP to this, then it would start broadcasting that SSID. But I'm not quite at the point, at least because I'm remote, I need to do some more configuration before I can actually connect an AP to this VSC. So the next step after I've put the information to connect to the VSC in here is I need to do the same thing we did for the switch. I need to click the sync not enabled and then do the enable config synchronization. And then what that's going to do is just make it such that it's going to take control, basically sync with the VSZ, and then I'll be able to create my own WLANs, and it will push that configuration to the VSZ. So now I'm in sync. I'm not going to create any WLANs just yet. So we've taken control of our ICX switch and the VSZ. Now we can start to do some of the configuration of the networking that we will need later in order to be able to connect and go through the user experience. So to do that, I am going to go to network and LAN. And this first network address, I'm going to create it a little bit differently, and just because I want to show you some of the things that this system can do. So I'm going to create a new VLAN, and I'm going to call it CC1. Make it our onboarding VLANs. I'm going to put VLANs. This should be on CC1 IGB3. I'm going to start this VLAN at 1000. Now we have a couple of options here. We can do per subnet. So in the auto increment here, we can do per subnet. And so basically what that means is if we create multiple VLANs, then or multiple subnets rather, we can assign a VLAN to each subnet automatically. And at the end here, it says n tags equals basically the number of tags, the number of VLAN tags equals subnets divided by the ratio. So right now, if we leave this set to 1, if we have one subnet, then we're going to have one VLAN. If we created 4 subnets, we would have 4 VLANs. I'm going to leave this as it is right now, just on per subnet with a ratio of 1. There are a couple of other options like per IP and then none. None, of course, being this, no matter how many subnets we put on here, it would just remain on VLAN 1000. We don't want that. So I'm going to change this back to per subnet with a ratio of 1. I'm going to hit create. Then what I'm going to do is come down and create a new network address. And this is going to be called CC1 onboarding addresses. Now, here, when we select the interface, because remember in the previous addresses when we created these, we selected the Ethernet interface. Here, we don't want to do that. We're just going to select the VLAN. Basically, we're tying this network address to this VLAN, and then the VLAN itself is tied to the physical interface. Now, I guess I'll start this at 10.0.0.1. It'll be a /24. I'm going to leave auto increment alone and the span alone, but I am going to check this create DHCP pool, and then I'm going to hit create. And so what that's done is it's created one. So I'll go ahead and refresh this page. We can see our VLAN is still going to be a single VLAN, right? VLAN 1000. And we have our, where'd it go? CC1 onboarding. So 10.0.0.1/24. Now that's not ideal, right? Because we're putting everybody not only in the same subnet, but the same VLAN as well. So we can make this better, right? One of the ways that we could do, because this is our onboarding addresses, right? So this is when the devices first connect. they're going to be placed into this onboarding network where they're going to be basically redirected to a captive portal, and they'll have to go through some authentication process, whether that's clicking a button to get connected, entering a code, or maybe signing up for an account. But we can make this better. We don't need to put everybody in a /24. So we're going to edit this. The other thing I wanted to show up before I do that, I can go to Services in DHCP, and here we can see that here we have our CC1 onboarding addresses. We can see the range .2 to .254. I'm going to go to Network and LAN again. I am going to edit my CC1 onboarding addresses. And it just so happens that I'm going to change this to /30. And how many /30s fit in the /24? Well, it's 64. So I'm going to change this to 64. So what that's going to do is now it's going to create 64 /30 networks starting at 10.0.0.1. So I'm going to update this. Okay, okay, I just need to do this. And then I'm going to edit the VLAN. And I should be able to select the address there. Onboarding addresses, update. Now, now what we have now is 64 /30s. And I'm going to edit this VLAN. Remember what we said, the number of tags, the number of VLAN tags is the subnets divided by the ratio, right? So the number of VLANs we would expect to be consuming right now is 64 because we had 64 subnets, and we can see that right here. So now we're using VLANs 1000 to 1063. Maybe we don't want to use that many VLANs. We could do, the other thing before I move on is we just changed this from a /24 into 64 /30s. I can go up to Services in DHCP, and I don't need to change this onboarding address at all because those 64 /30s still falls within this range, and the system will figure it out in the back end. We don't need to come in here and create 64 DHCP pools. So I'm going to go back to Network and LAN. We're gonna take this a step further. I'm going to edit, and I'm going to change this ratio to 4. Then what we would expect is the number of subnets, right? 64 divided by the ratio 4. We should end up with 16 VLANs. So we'll go ahead and update this. And now you can see we're now using 16 VLANs. And again, we just changed the VLANs that these networks are associated with, and we don't need to touch that VLAN pool. It is still functional. Now, when we had converted it from a /24 into the /30s, if we had done, maybe instead of 64, we had done 128, then we would have had to adjust our DHCP pool, right? Because it would basically be twice as big, and what we have configured there right now wouldn't cover that entire block. So now I'm basically going to just do the same thing that I just did for CC2, only I'll just do it the way we want right up front. So I'm going to do CC2 onboarding VLANs. This we know we want it on CC2 IGB3. We can start at 1016. And we want that ratio to be 4. So we're going to create this, and then we'll create our network address, CC2 onboarding addresses. We want to make sure we have the correct VLAN selected, in this case CC2 onboarding VLANs. We'll go ahead and leave that as 10.0.1.1/30. We'll make 64 of them, and I'm going to check the Create DHCP pool box and then hit Create. So now I'll go ahead and refresh this, and we can also see here that this is also using 16 VLANs. So where that might also be useful is in like an LPV or someplace just, if you've got more than 4,000 devices connected, or 4,000, well, probably not 4,000 accounts, but certainly 4,000 devices connected. You may not have enough VLANs to go around, so you can use that auto increment ratio in the VLANs to basically utilize more, or basically put more subnets inside of each VLAN so that you can, while it's still not ideal, obviously every subnet being in its own VLAN is better. this is still better than just everybody being on the /24 like we had it before. In this case, there's potentially four devices per VLAN. And so if somebody was to be in there and try to attack the network in some way, they would really only be affecting themselves and, at most 3 other devices instead of the entire network. So that's our onboarding network. We also need to have, of course, our account addresses. So I'm going to go ahead and create a new VLAN interface. This is going to be CC1 account VLANs. Since this is CC1, I need to put this CC1 IGB3. I'm just going to start at 2000. I know we didn't use that entire range before. Now, on the account side of things, we definitely want everybody to have their own VLAN, right? Each account is going to get its own VLAN. So I'm going to do per subnet, and I'm going to leave the ratio at 1. So I'll go ahead and create. And while I'm here, I'm just going to go ahead and do one more of these, which is going to be CC2 account VLANs. And that needs to be on CC2 IGB3. And let's see, I think we'll do 32, so we'll do 2032. But again, per subnet for the auto increment, and then the ratio should be left at 1. Hit create. So now I have all of the VLANs that I need. Now I can create the network addresses. So for our CC1 account addresses, I want to make sure that I have the proper VLAN selected. So CC1 account VLANs. And this time, I think I'll start this at 10.1. And this time we want /24s, and I'll make this, we'll only do 32 of them here. And I do want to create the DHCP pool. And I'm going to create one more address, which is our CC2 account addresses. Same thing, select the CC2 account VLANs. And I'll just start this one at .2. And I'll make sure to check that create DHCP box. And again, we're making 32 /24s. Go ahead and create. Now, if I refresh this, now you can see I've got 32 account VLANs on CC1 and 32 on CC2. And I have the network addresses created as well. So we have our networking. Before we go on to the next step, which is configuring, basically we'll have the networking in place, but we don't have, the thing that we're missing now is we don't have a way for a customer, we don't have any plans to sell the customer, but we also don't have a way for them to buy them. So that's going to be the thing that we do, one of the things we do next. And then we're going to start to create some of the actual configuration for the end user experience. But before we move on to that, I do want to, because right now we don't have a way to access the VSZ. So I'm going to fix that. There's 2 ways that we can do this. Actually, well, 3 technically, at least 3. We could create an open VPN on here, and then we could connect to that VPN, and then we could get to the VSZ that's behind the RxG that way. We could also use port forwarding, and we are going to configure that here. Primarily, not so much so that we can access the device remotely, but more so that because it's basically what's required for our remote APs to be able to connect to the remote VSZ's data plane. So the first thing I need to do before I can create an application filter is I need to know what ports I'm going to use. So in this case, I'm going to create a new application. An application is basically a list of ports, and optionally it could also include a WAN target. And of course, a WAN target being, a list of IP addresses or domains that if I attach a WAN target to an application, it basically just restricts the scope of the application filter to those ports that are going to those sites that are defined in the WAN target. I'm just going to call this VSZ ports, and I've got the ports here. And so I'm just going to hit create. Now I can create the application filter. And I'm going to call this one, I'll call it RxG, or VSZ RxG forward. And I'm sorry, I did not want to do a filter. That's not a forward. We want to go to packet forwards. So I already created the application. So what I really want to do is create an RxG forward. And then here I'll call it VSZ RxG forward, the application. I remember I created the VSZ ports. So if I start to type into this box, I can then select my VSZ ports. Now the IP address, this is the second IP address of CC1, so a public IP address. In this case, it's going to be 47.48.73.217. I don't need to do a destination port override. All I need to do is select the destination policy. In this case, it's the VSZ, right? Because that's where I want. The purpose of this is to get to the VSZ. So I'm selecting the VSZ policy. The only member of that VSZ policy is the VSZ itself. And so basically it's going to forward these ports on this IP address to the VSZ. So I'm going to go ahead and create. Now what I should be able to do is go to HTTPS 47.48.73.217 colon 8443, and I should be able to get to the VSZ. So now this does allow me to get to the VSZ, but this is not ideal, right? Port forwarding. Somebody could use a port sniffer and find the ports. The other thing too is while this VSZ does communicate on HTTPS, if this was another device that was behind the RxG that was on port 80, then all of my traffic, this way would not be encrypted over the internet. So this is not the ideal way to do it. A better way, if we wanted to get access to this VSZ in a more secure fashion, what we can utilize is the HTTP virtual host function of the RxG. And that is what that third certificate that we created earlier is going to be for. So now to configure this, I just go to System and Portals. And what I'm looking for is the HTTP virtual host, which is right here. So I'll go ahead and create a new HTTP virtual host. I'm going to give it a name. In this case, I'm just going to call it what the domain name is, just because I know exactly what that is. Now the host name for remote access is the same thing, lab04c.netlab.ninja. The target server IP address, so this is the private IP address of the VSZ, in which case this is going to be 172.16.0.5. And our target listening port is not port 80, but it's 8443. We want to check the use HTTPS, and we want to select that certificate, the lab04c netlab.ninja certificate that we created earlier. So I'll go ahead and create this now. So now what I should be able to do is to access the VSZ now by going to lab04c.netlab.ninja. Now I'm hitting the login for the VSZ that's behind the server. And now you can see it's actually secure. So the next thing that I could do is to get the AP connected. So to do that, I have the AP on my network already. Oop, that's not what I wanted. So I need to SSH to it. And its IP address on my network right now is 10.0.0.129. So I'm going to SSH to that. Super is the default username, and then sp-admin. And there's just one command that I need to run, which is set scg. Actually, before I do that, let's go back over here. Let's go to lab04c. netlab.ninja. Let's actually log in. We'll go access points, so you can see there's no APs connected. Then come back over here, set SCG IP, and it's going to be 47.48.73.217. And that should be it. That's all we have to do on the AP. And then we can come back over here, and it might take it a minute, but we should see that AP. We should see that AP get connected shortly. We'll also come back over here. Once that AP shows up, it will also appear in the network and wireless section here. And there we are. So there's the AP. Now it is connected to our smart zone. We still have one more thing we need to do, because it's not gonna, the way this is configured right now, it doesn't automatically move these into the zone that we want. So if I click on the staging zone here, we can see that this AP is in the staging zone. I want to click on it. I can click move, and I want to move it to the lab zone. I want to tell it yes. Now at this point, it'll connect to the VSE. If it needs to update its firmware, it will do that now. So usually it may take, depending on what software version you're running on the AP, this part can take a while for the AP to fully, get updated and then be able to be in use. If I come back over here though now, if I reset or refresh this, I should see that there's an access point that shows up in here now, and you can see it right there. So quick recap of what we've done so far is we installed the software. We turned the first machine into a master controller. We licensed it first. We turned it into a controller. We integrated, we pointed the second node, the standby CC, at the controller, and we formed a cluster controller, or rather a cluster, with both a master controller and a standby controller. And then we configured our new WAN. So we created 2 new uplinks, gave our system a public IP addresses. We set their domain names, and we retrieve certificates for them so we can access these securely. We also changed we also took control of one more thing we can do. So we also took control of the switch, the ICX switch, and the WLAN controller, and then we created what we needed to actually remotely access the VSZ. And then the other thing that we did is we created both our onboarding network and also our account networking. The one thing that I want to do is, remember, now we actually created some VLANs. We need to push those VLANs to our switch. So if I go to network and wired, in this case, I'm just going to push all of these VLANs to all of the ports here. If I wanted to, I could create a new switch port profile, and I could just select the ports I wanted to put these VLANs on. In this case, it's okay for them to be on all of the ports, so I'm just going to do that. I'm going to edit the switch port profile. I'm going to come in here. I'm going to select the account VLANs and the onboarding VLANs, and then I'm going to click update. Then what we'll see is it will try to sync. Right, and we can see that now here, sync attempt in progress, and we just have to wait a minute. And it will push that VLAN configuration to the switch. And then once it's done doing that, the config sync status will turn from the sync attempt in progress back to the green checkbox. And there we go. So now if I was to click on the sync here, and I could do download configuration. And now this is showing the configuration that it's pushed to the switch. So now you can see that it's pushed all the VLAN information there. So what the next step is going to be is to basically finish configuring this for our basically tiered service levels. And so I'm going to stop this video here now, and then the next video will go over configuring the tiered service levels.